Hello everyone and welcome to this exciting learning session. I am S.Madhavi, Assistant Professor, IT Department, Veltech Multitech Engineering College. Thank you for joining this video lecture. Today we'll be diving into an important and interesting topic, bubble sort and insertion sort algorithm. Whether you are a beginner building your foundation or someone brushing up your knowledge, I hope this session is designed you to grasp the core concepts with a clear explanation and example. So get ready to explore, learn and apply. Let's begin. An intro to the sorting method is sorting is nothing but arranging the elements in the order. It can be either in the increasing order or decreasing order. So, sorting takes an unordered collection and makes it an ordered one. So this is an example being given to us. Totally, there are six elements, and they are in the uh, unordered collections. So these unordered collections are being converted to the ordered one and being shown as the output. So this will be the final output for the sorting. And so we'll directly move on to what a bubble sort is. So bubble sort is an simple sorting algorithm that repeatedly steps through the list and compares the adjacent elements and swaps them if they are in the wrong order. The passes through the list are repeated until no swaps are needed, indicating that the list is sorted. And it is being named as bubble sort because the larger elements bubble to the top of the list with each pass. So hence the name came as bubble sort. And to say about this algorithmic steps, the step one is we have to start with the first element and we have to compare each and every adjacent elements, and if there is any wrong order we have to swap them in its correct order, and likewise we have to bubble up till the end of the list. So this is a procedure, and we'll deal it with an example too. So here it is being displayed here as the data is placed adjacent to each other, and the sorting starts from the one end, that is from the beginning, and till the end we'll be traversing it. And from the beginning, it will be comparing each and every adjacent elements. Adjacent datas will be compared, and if the datas are correct, it will be remaining as such. If not, we have to swap them and make them in the correct order, and this is how we'll be doing it till the entire list. And there is a possibilities that in the first pass itself the data may not be in the correct order, so we have to carry out the procedure again from the first. So this is being a repeated action being carried over here, and you'll clearly understand with this example. So as I've told you, this bubble sort is nothing but bubbling up the largest element. So here what we are going to do is that they have given a example like totally there are six elements being displayed over here, and if you see them they are in the unordered unordered collections of elements have been given over here, and our task is we have to arrange them, we have to sort them in the increasing order. We'll move on to the first step. So we have to compare the first two elements, that is the first element and the second element should be compared, and if there is any mismatch in their order we have to swap them in the sense we have to exchange one value with the another value, we have to exchange their places. So here 42 and 77 they are in the correct position, so then there is no need for swapping. And we'll move on, we'll bubble up, or we can say like we are going to move on to the next two adjacent elements, which is nothing but 77 and 35, that is being showed in this place. So when we take here again, they are in the incorrect order, so we have swapped their places. So 35 and 77 will they have came to its correct position. Now when we bubble up to the next two adjacent elements 3 and 4, the elements are 77 and 12. They are in the incorrect order, so we need to bubble up and we have to swap them to its correct order. So the result is being displayed over here. And then next 77 with 101, there is no need for swapping over here since they are in the correct order, so no need. So we'll move on to the next two adjacent element, which is nothing but 5 and 101. So they are in the correct order, so no need to swap. So this is the thing. So if you see, we have traversed all the elements and we have visited all the elements from the beginning to the end. And if you see here, the largest element has been moved to the end. It means it has reached to the end of the list, which means we have bubbled up the largest element to its correct position. So our task is we have completed the pass one. So in the next step we have to proceed the same thing again from the first, starting from the element 1 to the element 5, since element has been 6 has been placed to its correct position. So again we have to do it from the first. So the pass 2 begins from the 42 and 35. They are incorrect order, so we have to swap them. So the again the process will be started from the first to the last, and the second largest element will be bubbled up to the fifth position. So likewise we have to carry on so many passes until an correct order, that is an increasing or sorted order, is being found out. So this is the procedure of the bubble sort, and we'll see like when to use this bubble sort technique. Usually this technique is not used that much in the real world, but it can be chosen when, if you want to sort the elements in a quick manner, we can apply this algorithm. And next thing is that you can apply this bubble sort to the small set of datas, because since we have to repeatedly keep on checking the elements like from first to the last in its correct order, we have to bubble up the largest element to the correct position. So when we take a bubble sort, it works extremely on the small set of datas, and it nearly requires a sorted set of data. So for example, it works only for the limited like what to say, like a limited set of data only it will be accessible. So and there are some factors like when the bubble sort cannot be used, like it's a vice versa for the previous advantage. It can deal with only the large set of datas, and if you feel like if you want to work quicker, you can use this algorithm. But apart from that, we can choose some other sorting algorithm, because bubble sort is really very slow. And there is another example being shown here. If you see here, the numbers are not in or in the sorted order, which means they are in the increasing order. And so what we have to do is that we can apply the sorting methods only when they are in the unsorted order. So we'll mix it up. So the mixing of numbers have been given over here, and they are not in the sorted order. Our task is to make them in the sorted order. So if you take the bubble sort, our aim is that we have to compare the first two elements and they are not in the correct order. So what we need to do is that we have to swap them. So 5 and 6, they have came to its correct position. Now our task is we have to move to the next position, whereby the second and the third element has to be checked on. So 6 and 2, when you take the second and the third element, they are in the incorrect order, so we have to swap them. So it is being displayed over here. So see, the 2 and 6 has came to its correct position. So our next step is we have to choose the third and the fourth element. So I'll show it here. See here, 6 and 3, again they are not in the sorted order, so wrong order. So aim is that we have to again swap them. So now it has been in the sorted order. So again we'll move on to the next two adjacent elements 6 and 1. They are not in the sorted order. Again we have to swap them. Swap them is nothing but exchanging the values, the places. So 6 and 4, again they are in the wrong order, so we have swapped them 4 and 6. So now we have started and completed the procedure from the first to the last. And now, but then the element is again not now in the sorted order. So our task is again we have to carry out from the first, like we have to compare the two adjacent elements from the first to the last, and we'll be getting the final result in the correct order, like 1 2 3 4 5 and 6. So we have to carry on so many passes over here. To say about the algorithm, we have to um, like I'll show it with you this example. Actually this bubble sort technique, actually we have to start it from the first element, and we have to compare each and every elements, and we have to move to the next pair of elements, and we have to continue till the end of the array, and we have to keep repeating on this process until we get the elements in the sorted order and no more swaps are needed. So after this we'll stop this algorithm. So this algorithm is being represented to you in the form of the coding. So if you take here the first bubble sort is an function name, and here this method it is going to get the array integer, and after this the loop control passes contains the number of passes over here, starting from the last index. So it is being mentioned as ar dot length minus 1 until it reaches back to the and moves backwards to the 1. So it is being mentioned as I minus minus. And after this the second for loop, int j is equal to 1, j is less than or equal to j plus plus. It compares the adjacent elements from the starting index to the current pass limit. So each and every element will be compared over here, and then if there is any mismatch in the order we have to swap it. So for that swapping we have written this coding part. So it's a simple swapping logic concept. As you all know, it temporarily stores the left element in the temp variable, and it assigns the right element to the left, and places the temp again to the its correct to the right position. So using the third variable we have performed this swapping over here, and this is how it works. And to say about the complexity of the bubble sort, it is order of n square. Okay, we'll wind up with this bubble sort, and then we'll move on to the next sorting technique called as insertion sort. And to say about insertion sort, it is a simple sorting algorithm that builds the sorted array one element at a time. It works by iteratively taking each element from the unsorted portion of the list and inserting it into its correct position in the already sorted position. So this process continues until all the elements have been moved to the sorted portion, resulting in a fully sorted list. So if you see this diagram, you would have understood, you can able to easily understand the concept of insertion sort. Like when we are playing the cards, we can like we'll use to insert the number to its correct position. So the same logic is being carried over for this insertion sort also. So that's why the picture has been showed to you for you as an reference. So 5 2 4 5 10 elements are there, and the 7 has been placed to its correct position, which comes in between the 5 and 10. So we are going to place a new data into its correct order and to its correct position. So 7 comes in between 5 and 10. So that's how the insertion sort 2 works here, and you have some simple steps to follow it here. So we'll see one after the another. And when compared to the insertion bubble sort, this also is a simple sorting algorithm, whereby you'll be sorting the array elements one by one by shifting the elements towards left. So following are some of the important characteristics of the insertion sort. It can be efficient only for the smaller data sets, but inefficient for the larger data set, which we have seen already for the bubble sort. The same thing works out for here also. And when we take the insertion sort, it reduces the total number of steps if given a partially sorted list, hence it increases its efficiency. So we can say, like, if the numbers are somewhat partially sorted, it will be easy to do. If not, we have to carry out so many steps so that the efficiency will not be there. We can say, like, it is better than selection sort and bubble sort algorithm. And when we take the space complexity, it is very less. And because insertion sort also requires a single additional memory space, whereby we need to store the key value, that is as a temporary we have to store that value in some other place. So it needs one additional memory space for this insertion sorting, and it is also a stable one as it does not change the relative order of the elements with the equal keys. So as I've said, we'll be given a set of the elements, and that elements will be partitioned into two half. We can say, like, sorted array and the unsorted array. In this situation, we can say, like, we have our task is we have to take an element from the unsorted array, and we have to place them in the sorted array in its correct position. This is how the insertion sort works. So I'll repeat. The the array is divided, the total number of elements is divided into two: sorted array and unsorted array. Our task is we have to take each and every element from the unsorted array and place it over the sorted array in its correct position. So this is how the insertion sort works, and an example has been given to us. So as we all know, the algorithm works here by the following ways. Like, first we have to start from the beginning of the list as usual. We won't be considering the first element, we'll be starting it from the second element onwards. So since the first element is being in the sorted order, we assume, like, the first element is in its correct position. So we have to compare from the second element onwards. So the second element here is 1. We have to insert that second element in its correct position. So 1 will be placed before the 5. 1 will be placed before the number 5. And so now 1 and 5 has came to its correct position, and they are in the sorted order. Now we have to take the third element 6, and we have to push that 6 into its correct position, which nearby comes after the 5 only. So they are in the sorted order. Next we'll move on to the fourth element, and we have to take it as the number is 2, so we have to insert it into its correct position, which comes in between the 1 and 5, and it proceeds. So this is how we'll carry on with the example. And to summarize the algorithm, we can say, like, we have to start reading the list from the beginning to the end, and we have to start from the second element onwards, and we have to store that particular element into its correct order in the sorted array, and we have to add up each and every element and insert to its correct position. This is how the algorithm works. This is the next example. They have shown it with an pointers. So this rectangular box represents, like, this is a partition which is being going to separate the sorted array from the unsorted array. So 5 and 2 are in the sorted array and 4 is in the unsorted array. We have to take each and every element from the unsorted array, which is nothing but the 4, and this 4 has to be replaced in its correct position. So our task is we have to select the element, compare it, and then we have to shift the element and insert to its correct position. So we can, in short, we can say like insertion is nothing but we have to select, compare, shift, and insert the things. This is an algorithm for the insertion sort algorithm. So insertion sort is the function being used here, and we have to consider an array of numbers as a, r, r, and n is going to represent the number of elements being used here. So an for loop is given to us, which is going to read the element from the second position onwards, and it goes up to the last element, and we are going to treat the first element as already sorted. So we are going to start it from the second element onwards. So that's why in the for loop they have mentioned as for I from 1 to n minus 1, and not mentioned as 0 to n minus 1. Then and from there we will be storing each and every, the arri refers to an array at the position, at one position, so it's going to start from the array 1. So the second element will be stored in a key variable called as key, which is nothing but a temporary position to store the values. So we'll compare the values and place this key in its correct position. Now we have used here j is equal to I minus 1, which is nothing but to traverse backwards through the sorted part of the array, just to check it up. That's it. So next we have an while loop. So this while loop is nothing but it is going to check if the current element is greater than the key or not. If there is something like, if it is greater, we have to move that key to its original, like to its correct position. So for that sake they have given this line, and again j equal to j minus 1, which is nothing but to move to the left to compare to the next element in the sorted position. So and then array of j plus 1 is equal to key, which is nothing but once we found the right spot, what's our task is we have to place that key to its correct position. So for that sake they have given this uh, procedure. So this completes the insertion of one element, and again we'll go back to the looping again, starting from the third element onwards. Again we have to check it up, if it is in correct order it's okay, if not we'll be placing it to the place where it appropriates. That's it. So this is how it works on, and to summarize we'll have the comparison of the bubble sort and insertion sort. Bubble sort is nothing but here we'll be repeatedly checking the list and comparing the adjacent pairs, and if there is any mismatch we'll be swapping them. But in the insertion sort will be building the final sorted list by transferring one element at a time, which means here a pair is being, in bubble sort pair of elements have been compared, whereas here each and every element is being identified and it is placed into its correct position at a time. And when compared to the bubble sort, it checks the neighboring elements, that is the adjacent elements will be checked and it will be swapped accordingly, whereas in the insertion sort here it involves the transfer of an element to the partially sorted array. And in the bubble sort will have more number of swaps when compared to the insertion sort, it has only less number of swaps. Bubble sort is slower than insertion sort, whereas insertion sort is twice as fast as bubble sort. So if you want to do the work faster, you can choose the insertion sort when compared to the bubble sort, even though bubble sort is quicker, but then when compared to the insertion sort, bubble sort is somewhat slower. And a bubble sort will be very simple when to use, whereas in the insertion sort will be complex than the bubble sort. And to say about the complexities in terms of the space and the time, the efficiency, time efficiency they have given us, like for the best case efficiency for bubble sort, it has been given as order of n, and for insertion sort also remains the same, order of n. For the average case it would be order of n square, and for insertion sort also it will be order of n square. For worst case also order of n square and n square. The space complexity remains the same for both the things, so there is no that much difference. But then if you want to do a work like quicker, you can go for choosing the insertion sort when compared to the bubble sort. And to stay stability of the bubble sort and the insertion sort are stable, and it is both the sorting methods are adaptive too. And if you are going for nearly very small set of data, we can go for choosing this insertion sort. And we have almost seen the both the sorting algorithms, and I hope you would have now have a clear understanding of the topic. And that brings us to the end of this session. Until next time, stay curious, keep learning, and keep growing. Thank you.